Okay, welcome to part 5 of the final review packet video. So, number 34. Looks like we have a story problem. So, a boat leaves a port and sails 16 miles at a bearing of south 20 degrees east. Okay, so I'm going to draw my little grid. So, I'm going to go south and then 20 degrees east. So there's 20 degrees. And this length of this vector is going to be 12 miles. Another boat leaves the same port. Sorry, this is 16 miles. My apologies. The other boat leaves the same port and sails 12 miles at a bearing of south, 60 degrees west. That length is 12 miles. And the question is how far the boats apart. So I'm looking for that distance. So I've got a triangle. I have two sides and the angle between them, so I can use the law of cosines. So x squared equals 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of 80 degrees. Now, because I don't have any variables over here, I can go ahead and just type that whole thing in. That's actually my suggestion. So x squared is about 333.32. I take the square root to find x. And I get about 18.26 miles. Okay, 35. Vector v has an initial point at -2, 1, terminal point, like ending point, at 7, 6. Find its component form. Okay, so here's my vector. I'm looking for the components. So for the horizontal component, I'm just going to take 7 minus -2, which is 9. So that's the horizontal component. And then for the vertical, I'll take 6 minus 1, which gives me 5, which gives me the component form of the vector as 9, 5. Okay, 36. Turn the magnitude of v, which is 4i minus 7j. So here's how we write magnitude. And we can just use, really, a variation of the Pythagorean theorem. So we just take the square root of 4 squared plus 7 squared. So 16 plus 49 is 65. So we get radical 65. If you try to factor it, you will not find any pairs of factors, so this is simplified form. Okay, 37. Find the direction of vector v. So I'm going to draw a picture. The vector is -1, -4. And what I'm looking for is this angle right here. Well, I know that half a rotation is 180 degrees. So if I can find this angle in the triangle, I can easily find the direction of the vector. So labeling the lengths, this is 1 and this is 4. So let's say I want to find that reference angle. So I know that the tangent of the reference angle is equal to opposite over adjacent. So my reference angle is going to be equal to the arctangent of 4. Which is about 75.96 degrees. So to find theta, I'm just going to take the 180 degrees, the half rotation, and add the 75.96 degrees. Which gives me 255.96 degrees. Okay, number 38. We have a vector with initial point and a terminal point. We want to find its magnitude and direction. So I'm going to first put this into component form. So here's the ending point. So -1 minus 2 is -3. And then 9 minus 5 is 4. There's component form. So the magnitude, the square root of -3 squared plus 4 squared. So the magnitude is 5. So to find its direction, I'm going to go ahead and use the same process I did for number 37. I'm going to find the reference angle. I know this length is 3, and that length is 4. So my reference angle is equal to the arctangent of 4/3, because tangent is opposite over adjacent. Cute. Let's try that again. And I get 53.13 degrees. So to find theta, I'll take the half rotation and add the 53. Oh boy. Okay. I'm sorry, guys. Another mistake. Let's try that again. -3/4 is up here. Yeah, you probably figured that out before I did. So that doesn't change this. It's still 53.13 degrees. But what it's going to change is how we're going to figure it out. So we know that a full half rotation is 180 degrees. So theta is going to be 180 degrees minus the 53.13 degrees. So we get 126.87 degrees. Okay, 39, find a unit vector. So to find a unit vector, we're going to take the vector itself and divide by the magnitude. So the vector is 4i plus 2j. And for the magnitude, it's going to be the square root of 4 squared plus 2 squared. Okay, so we get square root of 20 for the magnitude. Do a quick factor tree, and we see we have a pair of 2's. So 20 is radical 20 is equal to 2 radical 5. So we'll rationalize the denominator. We get 4i radical 5 over 10, which is 2 radical 5 over 10i. And for the other, do something similar. 2j radical 5 over 10 reduces to radical 5 over 5j. Okay, for number 40, we want to find the angle between the two vectors. So here's the formula from our book. We just have v and w rather than u and v, but the process is still the same. So cosine of theta is equal to the dot product of the two angles. So for the dot product, we multiply the x-coordinates, or the horizontal components. So we get 3 times 6 plus negative 2 times 1. Okay, for the magnitude of u, it's the square root of 3 squared plus negative 2 squared. And for w, the square root of 6 squared plus 1 squared. So simplify. 18 plus negative 2 is 16. Here we get 9 radical 13, radical 37, radical 481. So to find the angle, we just take the arc cosine of 16 over the square root of 481. We get about 43.15 degrees. Okay, so we got the same formula that we used in the previous problem, but we have different information we need. So it says the angle between u and v is 2 pi over 3 equals the dot product over the magnitude, which is 40 times 15. So what is the cosine of 2 pi over 3? Well, if you don't know, our unit circle, 2 pi over 3, cosine is negative 1/2. So negative 1/2 equals u dot v over 600. So we'll multiply both sides by 600. And the dot product is equal to negative 300. Okay, 42, we have two vectors. We're supposed to determine if they're orthogonal, parallel, or neither. Well, orthogonal most of the time means perpendicular. And we know that they're perpendicular if the dot product is equal to 0. So v dot w is going to be equal to 2 times 1, okay, the 2 and the 1 there, plus negative 3 times 1. And the dot product is negative 1, so they're not orthogonal. Okay. In order to be parallel, they need to be pointed in the same direction. So one way you can do is you could find the slope of the vector, which is just the rise over the run. So the slope of v is going to be negative 3 over 2, and the slope of w is going to be 1 over 1. So those are obviously not the same, so they are not parallel.